I'm standing here to do a little bit of advertisement of the PV program here at AMOLF, because it's a special occasion that we have our 10th anniversary, already a little bit in the past. And I just want to highlight a few of the things that we've done, also because I think they're relevant for making connections to all of you, and show a little bit also how we measure the impact that we can have with research in PV here in AMOLF, but I think also in general that could be applicable. And so I have this booklet here, and for all of you who are interested, there's a pile of them there that describes the work that we've done in the past 10 years, and also our research vision for the coming years. And when we send out the email, we'll give a link so you can also read this online if you want to get the paper copy. So we were founded 10 years ago, and can you imagine, this is the cumulative installed PV capacity in the world. Where now every year we hear about these new record installations, but by then it just hardly existed. Right? So the NWO was quite visionary that they gave us the grant to start a program working in PV. And now here we are today. And we're not there yet, obviously, right? Because we have to go to 60 terawatts or so, 20, 30 years from now. And so this is our mission, linked to that climate agreement in the Netherlands, where we in the end know we have to do the fundamental science that makes this new technology possible. It's also a big economic development. But of course we're an institute for scientific research, so it's fundamental understanding of energy conversion concepts. And equally important, the fact that we just train you all, train people that become experts in sustainability and then find a job in that area afterwards. So this is a team, and you've seen not all of them today, because unfortunately Esther is sick and also Wiebke had to leave right now, but that's the 5 group leaders. Each of us have a research group that works on many different topics, and of course PV is an important part of them. So if we look back, we started working in this field when perovskites hardly existed. It just had come up, but in the meantime this is a distribution of topics that we worked on. So you see it's quite diverse in perovskite solar cells and contact layers, general light management concepts. That's how it started. That's where our expertise is. So if you like to connect for your research work on light management, understanding how light scatters in solar cells or how light is better trapped, we would love to collaborate. Right? We also have lots of expertise in contact layers, and as have many of you, but also there we can see many connections. And the same of course for perovskites. So again, this is also, I'm standing here just to show we're really open and hopeful to make connections to many of you. As we started our PV program, this is often how it goes, you get into other areas. In our case, for example, electron microscopy became a new area because we needed new tools to study the PV materials that we're working on. And in some cases, these tools just didn't exist. So we developed them ourselves, new electron microscopy techniques. And also you see nanoelectrochemistry. It turned out that the nanoparticles that we used initially to scatter light and trap are also very efficient chemical reactors. They can help drive chemical reactions. And so also that's an area that we're now even going further here at AMOLF. So what is our output? What is coming out of the program? Of course, you can always think that's publications and PhD thesis. And I'm showing these covers here just to also stimulate you. Go look at our website and see again what are these topics of these theses. What are they will link to many of the things that we could collaborate. And equally important, we train people, right? About 160 people now have been trained in PV and these related fields. And they go to many different types of jobs. You see them there. Many to a company, a technology institute. 9 of them actually became an assistant professor at a university. And this is also extremely important part of our work. So this is just a cartoon to show, these are many different, I know you can't read this, all kinds of solar cell designs that we've worked on. They go from light trapping coatings on silicon solar cells, thin film CIGS, quantum dots, perovskites, nanowire solar cells that we all have expertise in, 3-5 silicon tandem solar cells. And then this cartoon is to indicate all the new instruments, the spectroscopic tools that we've developed to analyze our solar cells. We published 20 or 30 or so perspective articles just to stimulate. We have ideas. You can keep the ideas for yourself, or you can publish them and hope people, pick them up and maybe start working on them. So here we had some cartoons on our most recent review, for example, where we say, okay, these geometries, they make better solar cells. If you're interested, maybe you work on them, work with us. And then here's Bruno's most recent paper here, Perspective, AI et al. Machines are about to change scientific publishing forever, of course, right? And also change scientific research forever. So that's the kind of things we also think about and publish about. This I want to advertise, if you didn't know, is we keep a record, literally, we keep the records of silicon solar cells on our website. So this is regularly updated. If a new record comes out, then we publish it on our website. And you will find the paper reference and the efficiency, but we plot it in terms of this graph. So this is open circuit voltage relative to the detailed balance limit. Right? And here's the short circuit current, and here's the open circuit voltage relative to the limit. So an ideal solar cell should be here. And so the record, say, organic solar cell is here and can use some light management, right? There's parasitic absorption and imperfect light absorption. And there's a big voltage loss. And this is a way that we introduced on this website to show, where needs to be work to be done. Is it in light management or is it in electrical management, carrier management? As I said, when we did microscopy, or we developed microscopy to do PV, several of these instruments, they just didn't exist, right? We developed it in our lab. And then we either founded a company or we worked with big companies like Thermo Fisher to bring these instruments on the market. So you can buy them now. So if you want to do EDX, which measures the crystal orientation of your perovskites, for example, you can go to EDX and buy the instrument. This is a fun one. These are 4 former alumni, people associated with LMPV, that work at a company that makes PV. Right? Isn't that fantastic? So here Benjamin Diver at Oxford PV makes perovskite silicon tannins. Piero Spinelli makes perovskite foils at Schall in Poland. Bonanu is working at Lightyear, integrated PV. And then there is Laurens van Dijk sitting. He showed his poster. If you haven't seen it, go take a look. He makes beautiful, see it here in the picture, integrated PV with all kinds of colors. Fantastic. The last thing I want to show is, in the end, we want to make impact with our research. Right? And that's a new thing for us to critically think about, because we think in terms of output often. We publish papers, we go to conferences, we write a thesis. Great, it's done. Right? But it's not done. Because impact you create if you take the next step, that output is somehow taken up by TNO or a company and brought to the next level. Then you still don't have impact, because impact comes if that then in the end is brought on the market and is used. Right? That's not what we do. Right? We have to be very careful. We do scientific research, but it's good to keep in mind, and we heard that in the first talk also, what would be the steps, your impact pathway, so to say, from the research that you do to actually making impact. So that means you have to first define what you mean with impact. So you want to somehow speed up the energy transition, right? That's the ultimate goal. Or maybe you develop tools that strengthen the economy, so we make money that flows back into the government basically. Make the PV chain more sustainable. Or we can say impact is just scientific research. We just lift the level of scientific knowledge. Perfectly fine. It's also an impact goal. And you can pick the ones that you like to be associated with. But impact comes after your work. It's not what you do yourself, but you need to be aware of it. And I have two slides here that look very technical, and I just can't show or list all the details, but I just want to say we asked an independent company, Roland Berger. If you're not familiar with them, it's like McKinsey, it's a consulting company. They do an analysis of the work that you do and of the research plans that you have. And then they make an analysis of what impact you have generated or that you will generate. So for example, here you see installed PV capacity, and by 2042 we'll have installed over 100 gigawatt peak if this growth fund proposal goes through, for example. That's also an impact from our work. Right? Not just us, but the whole group of people doing that together. We think that we can have a major fraction of the European PV production covered if that proposal goes through. And similar, there's analysis for how materials can be saved, how much CO2 will be saved if the panels will be made in Europe and installed here. And the last impact slide here was surprising to us while we were working on this. This takes a long time before you can make impact in the PV industry. Things go very slowly, innovations go very slowly. So you can make impact maybe with new products on a shorter time scale, but even that takes time. So right now, there's no economic impact yet from what we did here at AMOLF. But on the microscopy side, the new tools that we have developed, they are brought on the market. They actually make more than 10 million a year that flows back to the government. So that's a nice return on the scientific research that we did. So I want to end with this. Here we are today, and obviously we have a big target to go. And I showed you a little bit about the research that we're doing. What I didn't repeat here is what we showed earlier, the solar lab, and again the growth fund, where our goal at LMPV really was to bring this community together, and so that we can make impact with all of us together. And that's our goal, because we need you all to get to this target here. So with that, I want to end. So there's this book. You'll get a link if you want to read some of the details later on. And that ends my introduction.